Okay, welcome to the last part of the processes and memory module, where we're going to talk about how to extract the whole system memory. You can imagine that to do that in Unix and Windows, you need to somehow be root or administrator because no user should have the ability to examine all the system memory at any given time. So, yeah, being administrator seems to be really important, and also because we will need to extract also kernel memory to make sense of what's happening, we probably need to also be running at the kernel level. So the way to do that would be to inject some piece of kernel code now that's going to do our bidding, and to inject some piece of extra kernel code, what we need to do is load the kernel module. Recent, modern operating system kernels, because they're so complex, they need to deal with thousands of possible devices and different functionality requested for different setups for users. They have this ability to dynamically load and unload parts of code that they can execute. And Linux does that through the LKLM subsystem, the Linux kernel loadable module subsystem. And you can imagine that if you are now root, you can load a module that will do the same thing as we did with proc PID mem, like present a file to you that has the contents of all the system memory. Do that for the whole system. And this is exactly what the module fmem does that I have linked here. You can also see this short introduction. It's not from us, but another fantastic YouTube video that we found that explains how kernel modules, are loaded, unloaded, and all that stuff. But anyway, again, going back to fmem, you can load this module, download, compile it for your kernel, and run it. And then this is going to create a fake device. It's a device that just represents the sum of system memory. It's going to be under /dev/fmem, and then you can just dd out of it. And as we saw the previous netcat videos, you can dd and pipe that out straight to netcat, and then that's going to move all the system memory directly to another computer. I'm also linking to videos that we create here that again we perform this live memory dump for you, so make sure to check them out. Now, once you acquire some memory dump from a program, again, don't forget that this is a piece of evidence now, and you need to treat it with a proper respect. So of course you need to know the hashes that it has, so that you can make sure it's not being tampered. You need to log details about who is the investigator that got this, which type of computer you got from, what was the time that you got it. Again, hash it or maybe encrypt it, and back it up, of course, because you don't want to be on a system that is brittle and might turn off and now you lost. At least, if you have dumped to the disk, then it might be on a disk somehow. That's better. But even better, I want to say than doing all these things manually, is use one of the forensics format files, forensics file formats that we talked about, like EWF, the expert witness format. And EWF again supports memory dump, so you can use libwf to make your memory dump into an EWF file. So what is possibly in that memory dump? What can you get out of it? Well, you can really get everything. It's pretty amazing. You can get all the running process of the system, a list of the processes, maybe the actual memory of the processes. You can find which files this process had open, right? More funky stuff, like you can also see what network connections were on at the time of the memory dump, right? You might see that some process was actually connected to, for example, www.duckduckgo.com, for example. Or you might find even more amazing stuff, like what was displayed on the screen at the time of the memory capture, because that memory that belonged to the graphics controller has also been dumped on that file now. So if you know how to decode these data structures, you will be able to recreate what was displayed on the screen. You might find things like where the mouse was by knowing how the mouse driver was, or by what audio was being loaded in the sound card, and what was the user listening to. In case of Windows, you might also find things like registry types, and we're going to talk more about on the Windows module. But registry types are, you can imagine, they have configuration parameters in. They're like just configuration databases. And of course, config files for Unix. But the other very important thing that we can find is, apart from maybe passwords that have not been erased in memory. So for example, if the user just typed the password, if the program doesn't take care of zeroing out that memory, it's very probable that the typed password will also be in memory. But also things like encryption keys. Let's say you opened your GPG, your GPG vault. Let's say, so you have some sort of PGP encryption system, and you use the GPG agent to provide your key and unlock your vault. Then maybe the secret, the private key that you had for your GPG data is now somewhere in memory. And if you take a memory image at that point, you will find the private encryption key for PGP or SSH or stuff like that. If you have just the SSH thing, remote server, the private key part that you control to continue the SSH authentication is also somewhere in memory. So that might be in the memory dump, and then we can extract it from there. But what format are these files? Well, it's a pretty simple format. Usually they are just a linear raw dump, right? It goes from memory 0 to memory FFF, wherever it could reach. But there are also some different formats sometimes. For example, when Windows crashes, you might have seen the blue screen of death. On Xbox, I think it was red screen of death at some point, but there is this screen of death of Windows. When that happens, it might write a crash dump, a file with a .bin suffix in the disk. So if you examine disk and you find a crash file like that, you can analyze it and extract a lot of data from what was in memory when the system crashed. When you put your computer to hibernate, and I urge you to think about this because that happens very often, you turn off the lid of your laptop and you go somewhere. Well, if you extract the disk of the laptop, if you take the laptop that's still turned off and extract the disk, the contents of the memory have been written in a file on that disk. If there is no full disk encryption at that point, then not only you can read the data stored on the disk of that user, but you can also read the program, all the program system memory in the Hibernate file. When you run VMware and you run VMs there is this .vmem file format that you can dump the memory of a VM. Maybe, for example, to clone a VM, that's when this is applicable. You want to clone the VM so it transfers the memory. That is an example of where you can get dump out of a hypervisor like that. And of course, VirtualBox has similar dump VM core function. But now, okay, you can, if you have this file, you can of course do strings on it. You can open it with a text editor that is, that will accept giant files, for example, and just look at the binary. But there are tools there, and volatility is an amazing tool like that we're just mentioning here. And you can see the volatility video that we show you how it works. Volatility can take this file and it knows how to decode these data structures. It knows, depending on the operating system that you tell it, it knows at what offset these data structures are going to be at and how to decode them. So by using volatility, for example, you can give it an image and you can say, give me the list of running process at the time on that system. And it's going to find the process tables on the kernel and analyze that and give you an output like PS. And it's going to tell you these were the processes that were running at this time. Okay, it's scriptable. Volatility 3 now, that is the current version volatility. It has many plugins for many operating systems. And you can also go and write a plugin for something that is missing there. And I would say that this makes a fantastic project if you want to work on it. So finally, the first video is ours, but then this video here, which is more tutorial video, is from DFIR Science. Again, amazing resource on YouTube. Now, let's say you have a running system and it might be compromised. You have two options. You can either turn it off somehow. Maybe if you can't log into it, you might just pull the plug, or you can try to extract the running memory. If you can do that, then that might be extremely beneficial in finding out what's happening in the system. So now you kind of know that maybe you can put it to hibernate if it's a laptop, and then it's going to put that memory into a file, and then maybe you can extract that. Or there are some commercial grade sniffers, like cards that you can attach to it. Although while it's running, that I can see how that would happen. But there were some properties of the FireWire port. If you might not remember the FireWire port now. This was a port to connect the screens to a system, but through that port you could actually read the contents of the physical memory of the system. So if you have a laptop that has FireWire, check this post out and see how you can use just connecting a FireWire dongle there. You can actually read the state of the system. Or you can try, of course, to hack the running system and then, just dump the contents with devfmem as we described, or just take the disk contents with FTK imager and stuff like that. But if you actually turn it off, there's still a way that you can get the contents of memory. Now you know that RAM slowly, if you turn the computer off, it's being demagnetized and the data is being lost. However, if you have on these spray dusters that I'm showing here, the spray cans, you can freeze memory enough so that it preserves its contents way more. So this is actually called the cold boot attack, where you can take the sprayer, you can turn off the laptop, freeze it very, very quickly, and then if you freeze it enough, you can even go up to minutes until you start seeing loss on the contents of that memory. So you can actually freeze it, extract the memory, and go and put it on another laptop. That, of course, you need to have instructed the other laptop not to try to load new stuff on that memory that you want to examine. So you kind of need to tune your kernel to, for example, not load data on these DIMM slots, but only load it on some part of memory, and then leave the other one as untouched as possible. But anyway, you can freeze it, you can put it on another computer, and then you can extract it using devfmem, for example, as we described. If you search for the cold boot attack paper, I think it was published in 2008, and it's a pretty interesting paper. Thanks for watching this module. I hope you guys had fun, and we'll see you next week.